Hello, this is Mrs. Poland. This is for Algebra 2, Lesson 2.01, and in this video we're going to go over the skill Simplifying Algebraic Square Roots. So let's look at example 10. What we want to do is we want to first break up this expression so we have the radicand with the highest perfect square component, and in the other radical will be the non-perfect square factor. So when I think of 54, I think of all the different factors. I could take 54 and divide by 2 and I get 2 and 27. I can divide by 3 and get 3 and 18. I can divide, 4 doesn't go into it evenly, 5 doesn't go into 54 evenly, but I know 6 goes into 54 9 times, and 9 is the highest perfect square. So we're going to break 54 into 9 and 6, and now we're going to look at the variable x to the 5th. So variables are perfect square if the exponent is even, and we know that x to the 5th is 5, the exponent is an odd number. But I can break x to the 5th into x to the 4th, that would be the highest exponent, and x. Together, if I multiplied that out, I would get x to the 5th. So the highest perfect square component is x to the 4th, and the other factor is x. So when I simplify square root of 9x to the 4th, I get 3x squared, and the remaining factor is 6x. I can now multiply the x times the x squared. If I keep the base and add the exponents, x times x squared is 3x cubed, and then the radical, square root of 6x, cannot be factored further. Example 11, we're going to do the same thing. So we're going to carry down the y squared. We're going to break the 63x to the 7th y sixth to the perfect square piece and the non-perfect square piece. So let's think of factors of 63. Well, we have 3 and 21, neither are a perfect square. We know that 2 doesn't go into it, 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, but 7 goes into 63 9 times. And 7 times 9 is the highest factor. So we're going to put the 9 in the perfect square piece and the 7 in the non-perfect square piece. Now let's look at x to the 7th. So x to the 7th, the highest perfect square would be x to the 6th, and the remaining factor would be x. So in the perfect square piece, I would put x to the 6th, and the non-perfect square piece, I would put x. And finally, y to the 6th, that's a perfect square because 6 is an even exponent, so I put that in this factor over here. So let's simplify that. We get y squared times the square root of 9 is 3, the square root of x to the 6 is x cubed, and the square root of y to the 6 is y cubed. And that becomes square root of 7x. Okay, I can now combine the y cubed and y squared by multiplying it. I get 3x cubed. For the y variable, I keep the y base of y, and I add the exponent. 2 plus 3 is 5, square root of 7x. And this is my final answer. And example 12. Again, I'm going to carry down the coefficient of 8x cubed y. I'm going to break the radical into the perfect square piece and the non-perfect square piece. 9 is a perfect square, x squared is a perfect square, and y to the 6th is a perfect square. In fact, I didn't even need the non-perfect square piece. I'm just going to X that out. So I am left with 8x cubed y times 3. X squared is x. Y to the 6, the square root of it, is y to the 6 divided by 2 is 3. I now can multiply 8 times 3 to get 24. X cubed times x to get x to the 4th. Y times y cubed to get y to the 4th. And that is complete. So those are the skills: simplifying algebraic square roots.